to the video. So today we are going to solve problem 1231 on Leetcode, which says divide chocolate. But as you can see, I'm not on Leetcode. It's because this problem is a Leetcode premium problem and I don't have subscription for that. Therefore, I'm not coding on Leetcode. It's a hard problem and it has some basic, it has some good logic building behind it. So if you're able to solve this problem, it means your logic building is improving. Okay, so let's go to the problem. It says that we have one chocolate bar that consists of some chunks. Each chunk has its own sweetness given by the array sweetness. Okay, so we're given an array which denotes the sweetness of each chunk of chocolate. You want to share the chocolate with your k friends, so you start cutting the chocolate bar into k plus 1 pieces using k cuts. Okay, so I want to distribute the chocolate among my friends and myself. And I want to give myself that piece which has the minimum total sweetness.
Okay, so first of all, we are given two things. First, one we are given k. Let's take k to be 3, and then we are given the array sweetness, which contains the sweetness of each chunk of the chocolate. Let's take 1, 2, 3, 4, and 5. So basically, the chocolate has 5 pieces. The first piece has sweetness of 1, second has sweetness of 2, third piece has sweetness of 3, and so on. Okay, so that's pretty basic. Now, for example, this is our chocolate, right? And I have to divide it as the k is 3. This is the number of friends. Okay, so I want to divide the chocolate into k plus 1 pieces. I want to divide the chocolate into k plus 1 pieces. 1, 2, 3, 4. Okay, so now we can also say that k is all actually equal to number of cuts that we're going to make, right? K is also equal to number of cuts that we're going to make, right? So the question says that we have to basically arrange these cuts, make cuts at such places that the minimum piece, the minimum chunk that we get, that is also, as in, out of all the minimum options, that's the maximum. Okay, so first thing that I observe here is that my array sweetness is in the ascending order. And I have to basically make portions of this array. Basically, if I can say, I have to make sub arrays out of these, right? Therefore, it will come to my mind that I should use binary search, right? Because I have to optimize the cuts in these arrays, and also it is in ascending order. So it comes to me that let's try binary search. Okay, so for binary search, what do we need? We need a start pointer and an end pointer, right? So start is always going to be 1. Why? Because in the array or in the chocolate, there can be no piece which has 0 sweetness, if you want to understand in terms of sweetness of chocolate. And otherwise, if I want to explain in simple terms, the lower limit in the question given to us is 1. Therefore, the start is always going to be 1. The end, however, we'll initialize end with such a number so that it reduces our number of test cases, our number of iterations over the array, right? So to find that end, what I'm going to do is look closely, observe closely. This is gold. What I'm doing here, this is gold. What I'm doing here is I'll take sum of this array. Take the sum of this array and divide it by k plus 1. That is the number of pieces. Okay, the sum here becomes 5 plus 5, 10, 14, 15. Okay, sum becomes 15 divided by k plus 1, that is 4. That is how many pieces I have to divide this. Okay, this gives me 3 point something, right? And I will only get 3 because I am using the divide operator. I'll get 3. Now this is the maximum sweetness that I can get in any piece. If I divide it in 4 equal pieces, if I divide this given chocolate in equal pieces in regards to sweetness. Please keep in mind, the factor here is sweetness. If I divide this chocolate in equal parts in regards to sweetness, the maximum can be 3. Therefore, the maximum amount of sweetness I can get, the fourth member can get, is equal to 3. So the range of my choices, the range of choices of my sweetness, the sweetness that I can get, that's the range. The range now becomes 1, 2 and 3. Okay, start pointer comes here, end pointer comes here. Now if I apply binary search, I find out that my mid is 2. Okay, 2 becomes my mid. Now using this mid, what I have to do is I have to iterate over this whole array and check whether this sweetness, whether 2 is the maximum amount of sweetness that I can get. Does it satisfy the question statement? I simply need to now check that does this 2, does the sweetness level of 2 given to me satisfy the question statement? So for that, let's see. The mid has now become 2 and currently our number of chunks are 0 and the sum also is 0. Now I have to check. Now what I'm going to check is, now my check according to question statement, my check will be if my sum, when I iterate over this array, if my sum is greater than equal to mid, then I cut, as in then I make it a piece, then I cut a piece. Okay, so first let's see and then you'll get a better idea of what I'm saying here. Okay, so when the pointer comes to the 0th index, that is 1, the sum becomes 1. Is it greater than equal to mid? No, it's not. Okay, so I don't cut the piece here and I move further. Now my sum becomes 1 plus 2, that is 3. My sum becomes 3. Is that greater than equal to mid? Yes, it is. So I cut here. Okay, and I increase my chunks to 1. I cut the piece here and I increase my chunks to 1. Now as I have cut the piece, now I make my sum 0 again. See what I have done here? Since I have cut the piece, since I have removed that piece from the chocolate, I made my sum 0 again. Okay, now the pointer comes here. The sum becomes 3. Is it greater than or equal to 2? That is mid. Yes, it is. Sum becomes 3. I cut it. Now chunks become 2. Right? Sum again becomes 0. Right? When I move further, pointer comes here. My sum becomes 4. This condition passes. Yes, it does. The chunks become 3. Okay, chunks become 3. Let me make it a bit clear so that you guys can see clearly. Chunks become 3, right? And when finally the pointer comes here, after sum becomes 0, the pointer comes here. The sum is now 5. Is it greater than equal to mid? Yes, it is. My pieces then finally become 4. My chunks finally become 4. Okay, so let's just summarize what happened here. Basically, I checked this condition. Whatever passed, I proceeded accordingly, and now I got 4 chunks. Okay, I had to divide the chocolate into 4 chunks. I did so. But is it the right solution? It is also possible that the amount of sweetness I am getting may not be the maximum which I can get in some other combination. Is it not so? Yes, it is possible. The amount of sweetness I am getting in this particular arrangement of the chunks, I am getting the maximum, I am getting my sweetness, that is the minimum of the available sweetness, to be 3. The maximum sweetness that I got, because what the question says, the question says that out of the available sweetness, where the sweetness, let me highlight it, the sweetness is this is the available sweetness. There are 4 pieces, one has sweetness of 3, other has of 3, third has of 4, fourth has of 5. I have to take that piece which has the least sweetness. So currently, going by this, I am getting a piece which has sweetness of 2. But it may be possible, it might be possible in some scenario, in some, because okay, we can see, we can visually see that 3 is the maximum and 3 is the answer in this particular scenario. We can see that, but the computer can't see that. The computer can't see that. Computer goes by the algorithm. It is not seeing 1 2 3 5, the array is this, the k is this, and it's not doing all these things. It's going only by the algorithm. Therefore, yeah folks, so it became really messy in the previous slide. So here I've tried to summarize basically what we have done up till this point. Okay, please have a look and make sure that you get what I've written here. Okay, so now what I was saying earlier, that the computer works on our algorithm. It can't see that according to this given array and get this given k, our answer is 3 only. It has given us a possible answer, and we as humans know that that possible answer is the correct only, but the computer doesn't know that. The computer doesn't know that. So we have to put check conditions. So that check condition is here is going to be that if our chunk is greater than equal to k plus 1, we'll move our start to mid. Okay, if my chunks is equal to or is greater than k plus 1, my start moves forward to mid. Otherwise, if my chunks are less than k plus 1, then I need to bring my end pointer to mid minus 1. This is very important. Please, understand this very carefully. This is very important here. If this is not the case, then end goes to mid minus 1. Right? So according to this scenario, my chunks are equal to 4, that is k plus 1. So my start pointer moves forward and comes here. Yeah. So on checking this condition and on recalculating the mid, we find out that our mid is 2. Okay, our start pointer comes here, but the mid again is found to be 2 only. For 2 we have checked already, therefore we check for 3. The pointers remain same, but we check for 3. And on checking for 3, let's check. Okay, let's check for 3 also. What we were checking? We were checking that if our sum is greater than equal to mid, we increase the chunks, then we cut. This is what we were doing. If our sum is greater than equal to mid, then we cut. Okay, so now the new mid is 3. Okay, new mid has become 3. Now, if I add 1 and 2, my pointer first points to 1. This is less than mid. We continue moving, we continue iterating. 1 plus 2, 3. Is 3 equal to mid? Yes, it is. We cut the array there. Sum becomes 3 and we cut the array there. So on doing this, now repeating the same process that we did for earlier one, repeating the same process which we applied for 2 as mid, we can do for the same as mid, 3 as mid also. We can do the same process for 3 as mid also. I want you folks to go ahead and do it. I won't do it because I don't want to spoon feed you everything. Therefore I won't do it. I suggest you go forward and do the same process for 3 when we take 3 to be mid. Okay, you will find out that the answer comes to be same. Our chunks again come to be 4 only. Therefore, when we come on this condition, when we check for 3, when we iterate over the whole array, after iterating, you folks must have found out that the chunks remain 4 only. chunks remain 4. Okay, so now if the chunk is greater than equal to k plus 1, that is 4, if the chunk is equal to 4, our start goes to mid, right? Okay, as the chunk is equal to 4, what we are going to do, we're going to set our start equal to mid. What's mid here? Mid is 3. We're going to set start equal to mid. Okay, see clearly, start is equal to mid. We're going to do this. And what is this? Yes folks, what is this? Start and end have come at the same pointer. What is this? This is our break condition. This is our break condition. Now the computer knows. Now the computer knows that the previous answer was correct. Now the computer knows that the previous answer, whatever it was, 3, 4, 5, 6, whatever it was, now the computer says that this is the correct answer. Why? Because we have given it the break condition. The break condition is achieved. For binary search, what is the break condition? For binary search, the break condition is that the start and end pointer become equal in this case, right? So folks, I think that now this was a pretty tricky and extensive explanation, and I know that this seems heavy in the first go, so I suggest you go back and watch the video again if you're not through with the concept, because this is a very tricky question. The code is also not that simple. Obviously, if you know it, if you've practiced it once or twice, it becomes simple. But if you are watching it for the first time, it may seem a bit intimidating. It may seem a bit, over the head what happened just. So I suggest that you go back and watch the video again, twice or thrice. This question, folks, this question needs work. Don't shy away from it. Because if you're able to solve this question, then I guarantee you're gonna solve very tricky questions easily. This is a Google coding question. This question was asked in Google round, right? So folks, this question is pretty tricky, so I suggest to watch the video again. Don't shy away from the work. This question demands work. This particular question demands work, so I suggest to go back, watch the video again, twice, thrice. Don't shy away, put in the work. Okay, and after that, try to code it. If you're not able to code, then come back, watch the video, see my code.
Okay folks, so let's code it. I've initialized the array and the key variable. Now let me write down the function for maximizing public int maximize sweetness, I'll call it, right? It will take in the array sweetness and the integer k. Okay, so the start is gonna be 1, the end, as we discussed, is going to be the sum of the array. For that I'm going to use arrays dot stream, one second, arrays dot stream sweetness, right, dot sum, okay, dividing by k plus 1. So while start is less than end, this is my break condition which I was explaining earlier. This is that condition which I was explaining earlier. While start is less than end, int mid, the middle value is going to be start plus end plus 1 by 2. Okay, if can split, this is a function which I will declare later on. If can split, I will pass it sweetness, k and mid, right? If this is possible, then low equals to mid, sorry, then start equals to mid, right? Else our high is gonna come to mid minus 1 and end, sorry, what am I doing? Else our end is gonna come to mid minus 1, right? And I'm gonna return my start here. Okay, now I'll declare the function can split public static boolean it will return true and false. Boolean can split, right? It will also take in the array sweetness, sweetness, the integer k, and our middle element. The chunks are going to be initialized to 0, chunks 0, and the sum is also going to be 0. Okay, so for I have to iterate for the whole array for int I equal to 0, I less than sweetness dot length I plus plus. If my sum is greater than or equal to mid, this condition is already we have tested in the dry run. So if our sum is greater than or equal to mid, we're gonna increase the chunks and sum is gonna go back to 0. This will, one second, I missed a step here. I missed a step here. I didn't add the sum plus is equal to, what's it gonna be, sweetness, yeah, sweetness of I. I missed it. Okay, no issues, it happens. Okay, and now we're simply gonna return chunks greater than k plus 1, greater than equal to, sorry, greater than equal to k plus 1. Okay folks, so this is the code right here, and I think that you all must have done it yourself earlier only, but no issues. If you had to look through the code, it's okay, we all learn someday. And okay guys, that's it for this video. I hope you liked it. Please press the like button and share this video to your friends who are learning DSA, and support my channel. We're also starting a community #include. It's an all-inclusive, diversity inclusive community. You all can join the community with the on the Discord server and the Instagram. And I'll link my Instagram channel in the bio. And also the Google Forms are going to be out in a couple of weeks. So stay tuned. Some big things are really coming, guys. Some really big things are coming. Okay guys, bye bye. Take care. See ya. Have a good day.